there is a compartment which is filled with ammonium chloride and zinc chloride. So these ammonium cations enter into the inside layer made up of magnet, which is made up of mercuric oxide. Electrochemical cell, which is made up of lead plate and lead oxide plate, and the concentration of lead sulfur. Let's look at the working of nickel cadmium battery during fuel cell. So this is a fuel cell which is used molecules of hydrogen enter into the one electrode and undergo oxidation. So what do you mean by corrosion? Under the influence of moisture and oxygen, iron atoms as undergo oxidation. An oxygen molecule and 4H. Hello students, welcome to Learn It. In this segment, we are going to look at different kinds of batteries, their construction and working mechanism. Let's begin with the definition. Battery, it is an arrangement of electrochemical cells that can be used as a source of direct current at constant voltage. So battery can be a single electrochemical cell or multiple electrochemical cells, and we use this battery as a source of direct current, and the voltage provided by the battery is constant. In our daily life, we already come across two types of batteries. The first one includes the battery which can be used once and thrown. So such type of batteries are called as primary battery or cell. And second type of batteries includes we reuse it by charging. So such type of batteries are called as secondary battery. With respect to chemistry, we are going to define the primary battery as, in primary battery, the electrode reactions cannot be reversed by an external source of electrical energy. So the examples for primary battery includes dry cell, mercury cell. With respect to secondary battery, the electrode reactions can be reversed by an external source of electrical energy. Examples include lead acid battery, nickel cadmium battery and lithium ion battery. In this session, we are going to discuss in detail about the two primary batteries, that is dry cell and mercury cell, two secondary batteries, that is lead acid battery and nickel cadmium battery. So let's begin with the dry cell. So dry cell is also called as Leclanche cell. So it is consisting of positive and negative terminals, and in the positive terminal there is a metal cap and a seal, and a wrap is surrounding the Leclanche cell. So on this wrap we can see the branding, the manufacturer, the manufacturing place and the condition of operation. If you look at the internal parts, beneath the wrap there is a cylinder made up of zinc which acts as an anode. So under the metal cap we can see a graphite rod which acts as a cathode. So surrounding the graphite there is a layer of manganese dioxide along with traces of carbon. So in between the manganese dioxide layer and zinc anode, a compartment which is filled with ammonium chloride and zinc chloride. This is about the construction of dry cell. So with respect to working, we know this terminal is negatively charged because of the excess of or production of electrons, which is done by the zinc upon oxidation. So zinc upon oxidation gives Zn+2 ion and 2 electrons. So the form Zn+2 ion enter into the inside layer made up of ammonium chloride and zinc chloride. So this Zn+2 ion grabs the Cl- ions from ammonium chloride. So it may take the another Cl- from other ammonium chloride molecule. So there will be production of ammonium cations. So these ammonium cations enter into the inside layer made up of manganese dioxide and carbon. So the manganese dioxide undergoes reduction along with ammonium cation. to form hydroxide of manganese oxide and ammonia, and this reaction is irreversible. So that's why the dry cell or Leclanché cell is a primary battery, and this dry cell provides a voltage of 1.2 to 1.5 volts. Another important type of primary battery that we use in toys and watches is mercury cell. We know the upper part is positively charged, the down part is negatively charged. So with respect to construction, so the negatively charged part is made up of zinc amalgam, upon which there is a layer of separator which separates the anode from cathode. So the cathode is made up of mercuric oxide. Both anode, cathode and separator are surrounded by a layer of paste made up of potassium hydroxide and zinc oxide, which act as electrolyte. We can see both anode and cathode are made up of mercury content. That's why this is called as mercury cell. With respect to working, the zinc amalgam undergoes oxidation along with hydroxide ions provided by potassium hydroxide to form zinc oxide, water and 2 electrons. Here the zinc oxide is used so as to prevent the accumulation of Zn+2 ions and to keep the environment alkaline. At cathode, the reduction takes place by the mercuric oxide along with the water molecules which are produced from the anode to become mercury, which is in liquid state, along with the production of hydroxide ions. So this mercury cell provides the voltage of 1.35 volt. So let us look at an important secondary battery, which is lead acid battery. So this lead acid battery we have seen in our vehicles or even at our home. So as we know that our home appliances use alternating current, but this battery is a source of direct current. So in between the battery and our home appliances there is an instrument called as inverter, which inverts or converts the alternating current to direct current or direct current to alternating current. So while charging the battery, that inverter converts alternating current to direct current. While using the battery, that inverter converts the direct current into alternating current. So let us look at the construction of lead acid battery. So there are two grids which enclose the lead plate and lead oxide plate, which constitute an electrochemical cell. So this is an arrangement of one electrochemical cell. So one electrochemical cell is separated from another electrochemical cell by the separator. And the electrolyte present in the lead acid battery is dilute H2SO4. So the electrolyte is acid and the electrochemical cells are made up of lead. That's why this battery is called as lead acid battery. As the number of such electrochemical arrangements increases, the size of the battery increases. So which will increase the storage capacity of the battery or supply capacity of the battery, which in turn increases the price of this battery. Let us look at the working of lead acid battery by taking one electrochemical cell which is made up of lead plate and lead oxide plate. In between, dilute sulfuric acid is present, which is containing the ions H+ and SO4 - 2. When battery is connected to bulb, then this is called as discharging. So during the discharging, the lead atoms present on lead plate undergo oxidation to form Pb+2 ions and 2 electrons. The lead plate acts as an anode. So when formed Pb plus 2 ions react with SO4 minus 2 ions present in the electrolyte, there will be formation of lead sulfate, and it is present in the electrolyte. And these two electrons flow through the bulb, so bulb starts to glow. At lead oxide plate, the lead oxide consumes those two electrons along with the H plus ions present in the electrolyte. So there will be formation of lead ions and water molecules. So at lead oxide plate, there is a consumption of electrons or gain of electrons. The gain of electrons is called as reduction. The place where reduction takes place is called as cathode, which is positively charged. So the lead ions formed enter into the solution or electrolyte to form lead sulfate. The oxidation and reduction processes continue to take place. Then there is a continuous flow of electrons through the bulb, so the bulb starts to glow and the concentration of lead sulfate in the electrolyte start to increase. So the overall reaction is the lead plus lead oxide plus 2H2SO4. It is going to give us 2 lead sulfate plus 2 water molecules. So during the discharging process, the concentration of lead sulfate in the solution increases. So this process continues until the concentration of Pb plus 2 in the form of lead sulfate in the electrolyte reaches the equilibrium concentration with respect to lead and also lead oxide. So after discharging, we need to recharge it by connecting the terminals of external electric source. We should focus on the terminals of external electric energy source which are connected to the plates. So the positive terminal is connected to lead oxide plate, negative terminal is connected to lead plate. We know at positive terminal of the battery, the consumption of the electron takes place. That's why lead oxide plate is positively charged. So this will attract lead sulfate and 2 water molecules towards it, and they will undergo oxidation to form lead oxide, 4H plus ions, 1 SO4 minus 2 ion and 2 electrons. So the place where oxidation takes place is called as anode. So there will be deposition of lead oxide at the lead oxide plate from the lead sulfate. With respect to lead plate, which is getting the electrons from the battery, so lead sulfate will consume those electrons to become lead and SO4 minus 2 ions. Those SO4 minus 2 ions will move towards the electrolyte and lead will be deposited on the cathode or lead plate. So there will be deposition of lead and lead oxide during the recharging. So overall recharging process, the concentration of the lead sulfate in the electrolyte decreases and lead oxide is deposited on the anode, lead is deposited on the cathode. With this we can understand that water is one of the chemical which is involving in the working of lead acid battery. So as a normal temperature difference, the water starts to evaporate. So because of this, the concentration of the electrolyte solution in the battery start to increase. This will affect the working of lead acid battery. So as to prevent it, we add the distilled water from the outside, as we have seen in our batteries at home. Let's look at another secondary battery, that is nickel cadmium battery. We have seen nickel cadmium battery in many household rechargeable appliances and toys. So let us look at the construction. It is consisting of 4 layers of materials which are rolled to form a cylinder. So the outer layer is made up of cadmium and the inner layer is made up of potassium hydroxide electrolyte. After that we have the hydroxide of nickel oxide layer. After that we have the separator. So these 3 layers constitute a cell, and separator layer separates these 3 layers from other 3 layers during the rolling. So let's look at the working of nickel cadmium battery during the discharging process. Here we have connected nickel cadmium battery to the bulb. So this battery starts to discharge. Here cadmium acts as an anode and hydroxide of nickel oxide acts as an cathode. So cadmium undergo oxidation with potassium hydroxide, that is hydroxide ions provided by the potassium hydroxide. So there will be formation of cadmium hydroxide along with the 2 electrons. So these 2 electrons travel through the bulb. So bulb starts to glow. At cathode, hydroxide of nickel oxide consumes 2 electrons along with 2 water molecules. So there will be formation of nickel hydroxide along with 2 hydroxide ions. And this process continues, and at the anode there will be production of cadmium hydroxide, and at cathode there will be production of nickel hydroxide. This process continues and the bulb starts to glow. So when we connect the battery to the external source of electrical energy, so there will be recharging. The cadmium hydroxide, which has been formed from cadmium, takes 2 electrons provided by the negative terminal of the battery to become cadmium, which start to deposit on the cadmium layer along with 2 hydroxide ions. So at the positive terminal of the battery, the hydroxide of nickel oxide undergo oxidation along with 2 hydroxide ions. There will be formation of hydroxide of nickel oxide, which start to deposit on this layer to form hydroxide of nickel oxide along with 2 water molecules and 2 electrons. Let us look at an important technological application of electrochemistry is fuel cell. So this is a fuel cell which is used in cars. So this is a fuel cell which is connected to some cylinders filled with the fuel. So now the question comes, what is a fuel cell? Fuel cells are galvanic cells in which the energy of combustion of fuels like hydrogen, methane, methanol, etc. is directly converted into electrical energy. So in fuel cells we use fuels like hydrogen, methane, methanol, and the energy present in these fuels are converted into an electrical energy. So in this session we are going to discuss about one important fuel cell, which is hydrogen oxygen fuel cell. So it is consisting of two outer jackets so as to provide the hydrogen and oxygen. Within those outer jacket we have porous carbon electrodes which is containing the traces of platinum or palladium which act as catalyst, and both of the electrodes are separated by a separator which is filled with potassium hydroxide electrolyte. In hydrogen oxygen fuel cell we use hydrogen gas and oxygen. So the byproduct of fuel cell is water, which is environmentally friendly. Let's understand the working of hydrogen oxygen fuel cell. So when both the electrodes are connected to bulb or a motor of a vehicle, then this reaction happens with respect to hydrogen. So we are going to feed the fuel cell with hydrogen at one side, oxygen at the other side. Then two molecules of hydrogen enter into the one electrode and undergo oxidation. So the place where oxidation takes place is called as anode. So the H plus ions produced upon oxidation react with OH minus present in the electrolyte to form water. So these four electrons start to travel through the bulb and present on the other electrode, which will attract the oxygen molecule. So bulb starts to glow. So when one oxygen molecule reacts with 4 electrons along with 2 water molecules, then there will be formation of 4 OH minus ions. So here the consumption of electron takes place by the oxygen molecule and water molecules. That's why this is called as reduction. So the place where reduction takes place is called as cathode. So there will be production of 4 OH minus which were consumed before. At the end, 2 water molecules are formed. So let's look at an important electrochemical phenomenon which happens in the nature called corrosion. So what do you mean by corrosion? So corrosion is a process of deterioration of metal as a result of its reaction with air or water or environment which is surrounding it. So here the metal degrades because of its own reaction with the environment surrounding it. So if the metal is an iron, then the process of corrosion is called as rusting. Let us look at the process of rusting. Consider a nail. It has iron atoms. So under the influence of moisture and oxygen, as we know, moisture is containing water or acidic substance, which is going to give us H plus ions. So these H plus ions accumulate near the iron atoms along with oxygen. So when this system creates, the iron undergoes oxidation to form Fe plus 2 ions and 2 electrons. So these 2 electrons go near to oxygen and 4 H plus ions. Like that, another iron atoms undergo oxidation. So when 4H plus ions consume 4 electrons along with one oxygen molecule, there will be formation of 2 water molecules. So this is the reduction process, and the conversion of iron into Fe plus 2 is oxidation process. So redox reaction happened. So the E0 for conversion of H plus ions into water is 1.23 volt. So when such 4 Fe plus 2 ions react with one oxygen molecule and 4 H2O molecules, there will be formation of 2 Fe2O3 molecules and 8 H plus ions. So when one Fe2O3 reacts with certain number of water molecules, then rust, that is Fe2O3 x H2O, is formed. So this rust accumulates on the surface of iron nail. The process of rusting accelerates if there is a contact of electrolyte, or if the iron atoms are present in the salt water. So this process of rusting can be prevented by applying the paint over the surface or coating by using other metals. It may be zinc. Then that process is called as galvanization. So during galvanization, the zinc is deposited over the other metal. So this completes electrochemistry chapter.